Hey guys.
Hi.
Apparently Zoom did not want us to say goodbye last time. Would you please tell them that we started the session? Can you find the link?
Okay.
Or do you need the link?
I don't know. I went from my phone.
Okay.
I always go from my laptop.
All right. Send them. Please tell them to log in. And if anyone is having trouble finding the link, I will upload it on Classroom.
Mira send us the link on the group.
You're going to send the link on the group?
No, Mira already sent it on the group.
Okay, excellent. All right, very good. Yes, Judy.
Miss, what happened to the first session?
Zoom collapsed worldwide.
Oh.
Yes, it happened. This is true. This is true from, I swear. It was very weird because I kept telling you that we're going to say goodbye, and then apparently Zoom, I was just telling Ruqayya, Zoom did not want us to say goodbye at that time.
When the Zoom
I thought that I was disconnected, and then Mira, Judy told me that she also is disconnected, and then Mira, and then Nancy, and then
yes, and I thought that I had internet problems, and then it turned out that yes, that Zoom had a problem. Okay, guys. Yes.
When the Zoom closed by itself, I thought this was the last session and we are not going to say goodbye to each other.
No. I was very keen to tell Mustafa to find another session so that we can say goodbye to each other. So yeah, so we made it happen. Okay, please tell them to hurry up and come in and
I told them in the group.
Okay, and open your resource pack, page 37. Page 37, yes. Did you open it?
I opened it.
Okay. Yes.
When we opened when we opened page 37, the Zoom closed by itself, like we didn't.
Yeah. The problem is with page 37.
Yes.
We're only 7.
Yeah, I'm waiting for the rest. Where are the rest?
I don't know.
They died.
No. This is so evil. No, they didn't. They're fine. Okay, so yes, this is it, page 37. I have to start. I will not be able to wait for everyone else. So right here, use your textbook to help you fill in the blanks. How do forces affect motion? Objects move or stop moving because there are what acting on them. I will answer the questions, okay? I will answer them so that we don't lose time. So I will answer them quickly.
Okay.
So there are forces acting on them. Okay. Number 2, forces on an object can act in opposite directions if these forces are equal in size, then they do not cause a change in the objects. This is the balanced force, guys. The balanced force is when the forces are equal and they are working in the opposite directions. They are working in the opposite direction and both of them are equal. So in this case, the object will not move. They do not cause a change in the object's movement. Okay. Forces that are you writing, Lena? Okay. Forces that are equal in size and opposite in direction are called, I was just saying it right now. Yes, Mira?
Yes.
Yes, balanced or unbalanced. If they are equal in size and opposite in direction.
Opposite in direction.
And equal in size, equal in the amount of force. Are they balanced or unbalanced?
Oh, okay. No, they're balanced.
Balanced, yes. Forces that are not equal in size or are not opposite in direction are called what? Unbalanced force, yes. Unbalanced force can affect the object's movement or shape movement, shape or both. Movement, shape or both. You can also write movement, direction or both. Okay? You can write movement, shape or both, or you can write movement or direction or both. Okay?
Okay.
Okay, how do forces affect acceleration? What is the meaning of acceleration? Acceleration means the change in speed, not speed, the change in speed, whether speeding up or slowing down. This is what acceleration is, the change in speed. Okay? The motion of an object is affected when the size of the what acting on it changes. Of course, the size of the force acting on it changes. All right, should I erase?
Yes.
Yes.
Okay. I'm going down. Who colored on my screen? Come on, guys. Who colored? Someone colored my screen. Who did this?
I don't know.
I don't know.
Okay. Let's just erase it and disable annotation. Okay. The motion of an, yeah, we did this. An object will move what when a greater force is used on it? Faster. The object will move faster. Of course, it's like when you push something really lightly or you push it really hard. When you push it lightly, it's going to move a small distance, but when you move it hard, it's going to move a large distance and with a faster speed. Greater and lesser forces are used to make objects move faster or slower, of course. Okay, how does friction affect motion? Number 9, friction is a force that acts opposite to motion. Friction acts between two surfaces that are in contact. You can write in contact means that they are touching each other, okay? So they are in contact, that are in contact. And number 11, what surface produces more friction than a what surface? A rough surface, of course, produces more friction than a smooth surface. After finishing this, I want you to open page 93. Page 93 after finishing this. Okay. Did you finish? Should I erase?
Yes.
Okay. I will open the, yes, this one. Okay. This is page 93. Okay. Number 1 says a magnet is an object or a material that attracts things. So the first word will be attracts. Things containing iron or steel and nickel or cobalt. Magnets can attract and repel each other according to which poles are facing each other. So they might get attract or repelling. Number 3, all magnets have a north pole and or an south pole.
South Pole.
Yes, excellent. The north poles and south poles of two magnets will attract each other. Yes, very good. Magnetic force dash when magnets are close together. Magnetic force are strongest or stronger when the magnets are close together, and they are weaker when the magnets are further away from each other. All right. Are you done?
Yes.
Okay. I'm going to go down.
Miss, when we finish this session, can I ask you a question?
Yes, sure, dear.
Okay.
Okay. Number 6, a magnetic field is the region of magnetic force around a magnet. And then number 7, an electromagnet is a magnet produced by a or an electric current, and this is why it's called an electromagnet. This electric current moving through a wire that can be turned off with a or an switch. We can actually, you know, this from the last trimester, that we can control the electric current with the switch. We can open or close it. Number 8, the amount of current determines the strength, how strong the magnet is. If you put too much electricity in the wire, then the magnetism will be more. If you put just a small current or a very weak current, the magnet will not be working so good. Industrial use of magnets are, we said that the electromagnet, we use it in recycling or separation. So if you would like to write recycling and separation, this will be fine. And the last question, number 10, types of magnets are, you will write all the shapes that we know about: bar, ring, disc magnet, horseshoe, and wand, for example, or rod. And this is it. We're done with the book. So now we're going to go through the PowerPoint. I will show you the PowerPoint that I made, and that I really highly recommend that you use it to revise from it right before getting into the exam on Sunday. Your exam.
We didn't also make 95 and 94.
95 and 94 are actually activities. 95 and 94 are activities. If we were at school, we would be able to do them, but unfortunately we cannot because
Miss,
of, yes?
My mom said that we will stay online for 5 years. I don't
We
know.
will be near 9.
I am not quite sure. I don't know about this.
No.
Maybe we will. Maybe we won't. I don't know.
We won't.
No. They don't want to. Okay.
No.
So this is the PowerPoint I'm telling you about. Your exam is on Sunday at 6 p.m. So before Yes, before going into the exam, this is what I want you to revise, okay? Before going into the exam. They are only, as I told you, you have like they are six slides. Two of them are the title and the contents. So they are actually 4 slides only, okay? And I put all the highlights that you need to learn or that you need to revise right before getting into the exam in it. Ali, do you want to ask a question?
Yes.
Yes.
Miss, are you going to do the PowerPoint or
what? Yes, I'm going to go through.
maybe,
I'm going to go through it now. Do you need something?
no, that's just what I needed to ask. Right?
Oh yeah, we're going to go through it right now before we leave. So guys, so as I told you, I put all of the highlights, the most important information that I need you to revise right before getting into the exam. The first thing is, what is force? And we know that all of the forces that we have around the world is originally a push or a pull, but we give it different names because we cannot just say it's a push or a pull. We have to give it several names. Like what? Like the ones that we have learned about this year: gravity, water resistance, air resistance, friction, upthrust. All of those are forces that are originally what?
The session will end when?
At 2:10.
Okay, thank you.
You're welcome. So originally all of the forces is a push or a pull. Okay, what is the effect of the force? It can change speed, it can change the direction of an object, it can change its shape, or it can make it even start moving or stop moving. Forces could be balanced if they are equal to each other, and this will not make the object move, or they could be unbalanced, and this is where they are not equal and the object will move eventually. What is the difference between mass and weight? We know that mass is the amount of matter inside any object. It's like when you have a bag and you fill it with books. So this is the mass of the bag, and it doesn't change wherever you go. If you're going to change the planet that you are living in, your mass will stay the same. As I told you before, exactly like when you fill your bag with 20 books and then close the bag and put it on your back and you just travel anywhere. Will the books change their number? No, of course they will not. They will stay 20 books inside your bag. So mass never changes. What is its unit? Grams or kilograms. And how is it measured? It's measured by bathroom balance or kitchen balance, for example, or any balance that I told you we stand on it or we put the object on it. Now, what about the weight? The weight is a type of force. Why? Because it is affected by gravity, and gravity is a force that pulls us to the ground. So since weight is determining, or it is depending on gravity, so this is why weight is considered a force. So this means that it will change from one place to another according to the gravity of this place. So if you are on Earth, your weight will be different from if you are on Mars, from if you are on Moon, because each one of those have their own gravity. And weight is affected by gravity, so of course the weight will change. The unit of the weight, because the weight is a force, will be Newton, and it is measured by what? By force meter, or it has another name, which is the spring balance. Now, what is the law of weight? And expect that I will get you a question like an equation. I will give you, like just like the quizzes, I will give you the mass of an object, and the gravity of the planet that this object is on, and I will ask you to calculate the weight. And as I told you, in science, you are allowed to use a calculator. All right, so you can use a calculator to find the weight of this object. What are the examples of forces that we have learned about throughout this trimester? You have number one is the gravity, then the friction, upthrust force, water resistance, and air resistance. Gravity is discovered by Isaac Newton, the scientist who was sitting under the apple tree and the apple fell on his head. His name is Isaac Newton, and this is why we took his name as a unit for force. And gravity is what? It is the force that is pulling everything towards the ground. What about friction? Friction is a force that works always in the opposite direction of the movement. And this is the key word when it comes to friction. It works in the opposite direction. If something is moving this way, the friction is trying to stop it or is trying to pull it back the other way. How can we reduce friction? This is a very important point, guys. How can we reduce friction? By with oil or water. Those things reduce friction. What's the meaning of reduce? It means that it decreases it or make it less. So if I spilled some oil on the ground or on the floor, it will become more slippery, and this is because it has less friction. The friction is reduced. So what are the things that reduces friction? Oil or water. Number three, the upthrust force is the force responsible for pushing things up and make them float on water. Okay, the things that makes or the force that makes objects float on water is the upthrust force, because it is a pushing force. It pushes objects up. What about water and air resistance? Water and air resistance, both of them are a type of friction. A type of a friction force. What?
Can I go to the toilet?
Who are you?
Nancy.
Make it quick, please, Nancy. Okay.
Okay, thank you.
You're welcome. So the water resistance and air resistance, both of them are a type of friction force. Can anyone tell me why? Why do we consider them friction force? Why do we consider them a friction force? Yes, Ali?
Miss, what was the question?
The question is, why do we consider water resistance and air resistance a type of friction force?
That's because they go the opposite.
Yes,
that's because they go the opposite direction.
Yes, they work in the opposite direction of the movement. And in order to have friction, you have to have two surfaces rubbing against each other or in contact with each other. In case of water, those two surfaces is the object and the water. In air resistance, it will be the object and air. So you still have two surfaces rubbing against or in contact with each other. And as you said, this is an excellent point. They are working in the opposite direction of the motion. So what is water resistance? Water resistance, as I told you, is a type of friction force, and you can reduce it by building a narrow or a streamlined boat. This way you are going to reduce water resistance. What about air resistance? It's also a type of friction force, and we know that large parachutes land slower than small parachutes because of the friction of the air resistance. Okay, now this is everything that you need to go through in force lesson. What about heat? You have thermal energy. This is the first definition that we talked about. Thermal energy is the energy of moving particles. So inside any object, you have particles and they keep moving. If they move faster, this means that they have thermal energy inside them. What about heat? Heat is how we feel? How do we feel when the object has thermal energy in it? So the thermal energy flows in the object, and this is what heat is. It's the flowing of thermal energy from one object to another. Now, how can we measure heat? We know that thermal energy is the energy of moving particles. We know that the heat is the flow of thermal energy. Now we want to measure the heat with an object or with a tool that will help us determine the exact amount of heat or thermal energy in an object by this is what we call a temperature, which is how hot or cold an object is, and it is measured by what? By a thermometer. What is its unit? Degrees Celsius. And the thermometer contains, inside the thermometer, there is a liquid that is really sensitive to heat and expands when it's heated. This liquid could be alcohol or mercury. Okay. Some temperatures that we know about, water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. And we know that the body temperature is 37 degrees Celsius. Now, what are the heat sources? You have the main heat source is the sun. And then you have other heat sources like what? Like light bulbs, stoves, rubbing your hands together, fire. All of those things are considered heat sources. Heat transfers from where to where? This is logic. This is common sense. If something is more hot, then it will transfer to the colder object. So from hotter or from warmer to colder. Okay. And the last thing is the thermal conductors and insulators. Thermal conductors are the ones that welcomes heat. They love heat and they allow them to pass through them easily. Like what? Like all metals, which include steel and iron. While insulators are not very welcoming. They prevent or they do not like heat to pass through them. They do not allow heat to pass through them. Like what? Like wood or plastic. Okay. Now this is all the or heat in a nutshell. Okay. The last thing is magnetism. What I need you to know is the types of magnets or the shapes of the magnets that we know about. Bar magnet, horseshoe, ring, wand, rod, and disc. If I, for example, told you glass magnet is a type of magnet, does that make sense? Is there anything? Yes, there is nothing called glass magnet or bottle magnet or phone magnet. There is nothing called this way. We only know those are the known types of magnets that we know about: bar, horseshoe, ring, wand, rod, and disc. Okay. Now, what are the magnets? Yes. Can I what?
Complete your words, and when we end the session, I'm going to tell you something before we end the session.
All right, dear. So the magnetic materials, we have only 4 magnetic materials. Please remember this. We only have 4 magnetic materials: iron, steel, cobalt, and nickel. Those are only the magnetic materials. Those are the materials that get attracted to the magnet. Any other thing, whether it's a metal or a non-metal, it does not get attracted to the magnet. As long as the metal is not iron or steel or cobalt or nickel, it will not be attracted to the magnet. Okay? We all know that magnets have 2 sides, 2 poles, north and south. The similar ones facing each other will repel. The different or the opposite ones facing each other will attract. What's the magnetic field? It's the area of magnetic force around the magnet. If this is a magnet, then there is an area surrounding this magnet which we call the magnetic field. If any magnetic material comes close to the magnetic field, it will attract or get stick to the magnet. But if it's away from it, it's not around the magnet, then it will not be attracted to it. So the magnetic field is the area of magnetic force around the magnet. What is the magnetic keeper? The magnetic keeper is a piece or a bar of steel that we stick to the magnet to preserve its force, to keep it working for a long time after storage. What is an electromagnet? We asked the question, if we have a natural magnet, can we make a magnet? We said, yes, you can, using the electric current. How? You you get an iron or steel nail and you coil a copper wire around it and you connect it to a battery. This way you are making a magnet. Now, what about the safe handling and storage? How can I store or how can I deal with the magnets? The highlights are: do not bang magnets to each other, wear safety goggles, and don't put magnets next to credit cards or mobile phones or TV or computer screens. It's going to erase it, or it's going. We said that this magnet affects it. Where were you, Mira, when we said so? The magnets affect and erases the magnetic strip in the credit cards. It just ruins it. It
Miss,
does.
my magnet was going to erase all my laptop. I was
exactly.
putting it far from my laptop, and then my cat just got it next to my laptop, and then I was so scared.
Yes, it could ruin your mobile phones or TV screens or computer screens. Yes, because they're very forceful. Yes.
How many kids do you have?
Only one, dear. I have one girl.
You mean 2 kids because you have one boy in your stomach.
Yes. When he comes, he's still inside. Okay. And the last thing is, don't store magnets in wet areas. You have to keep it in a dry area so that it won't lose its magnetic force. Now, this is it, guys. What time is it? It's 2:13. So
No.
So yeah, before we go, can we take a screenshot?
Yes.
So yes, please open your camera, please, so that I can take a screenshot of all of you. Someone left immediately. Someone, once I said it's over, they just left. Yeah,
we're
where
only
are
7.
It's okay. Ali, yeah, Ali is here. Okay.
I look horrible.
And
me too.
No, you look lovely. All of you, you look lovely. Okay.
I want to tell you something.
Yes, Lina.
If we are going to be online for 5 years, I will quit the school.
Yeah, just work anything.
I will break my laptop, Miss. I'll break my laptop.
You can work. You can start working, Lina.
Yeah.
Like get a job or something. Yeah. Okay, guys. Look at the cameras and smile. Where is Mira? Where are you, Mira?
I'm here.
Okay. You
Mira's
look
putting
lovely.
her
Yes, you
finger.
look lovely. I swear. All of the girls looks lovely. And Ali, of course. Okay, come on, guys. I'm going to count till 3, and then you have to smile.
Oh, okay.
Okay. 1, 2, 3. Mira, you're not going to join us? Okay, one more for Mira. Come on.
Okay.
Okay, 1, 2, 3. Okay, guys, I will miss you so much. I will try to visit next year. And until then, I hope you are all healthy.
Miss, who's going to be with us?
Doing great. I don't know, dear. I don't know. But I'm sure that it is a lovely person, of course. I will make sure of this.
I would say, and I would say the whole summer, I hope Miss Nipno will be with us.
Oh.
Yes.
This is so nice. I'm going to miss you so much. Say hi to the rest of the class. I was hoping to see them before I leave. So it's okay. We might see each other soon, inshallah.
Miss, can we have another session?
Yeah.
Another what?
Session.
Another
Another
session?
session.
No,
Yes,
unfortunately not.
Miss, I'm very hungry and
No.
I'm very hungry and my mom and my grandma are cooking and the food
Smell.
is yes.
Yeah.
It makes me more hungry.
Yeah, I am going to my mother's home today too, and she makes lovely food. So I am hungry from now. So I know how you feel, dear. All right. I see you soon, guys. Bye.
Bye.
Bye-bye.
Bye. Bye.
Bye. Bye.